Hello everyone, welcome to today's class. First we go through the question. The question is, design a propane loop with the following parameters. Vapor propane with a molar flow of 100 kilomoles per hour at 50 degrees centigrade and 398 kPa is compressed to an outlet of 2000 kPa, which was further cooled to 25 degrees centigrade, causing a change from vapor to liquid. This liquid propane is passed through an expansion valve to attain an outward pressure of 200 kPa before being heated to its startup parameters and sent back to the compressor. That's question one. Question two is, using the above parameter, design a propane loop in a manner that the product from the expansion valve passes through a heat exchanger to absorb heat from the shell side, which has a feed of vapor propane at 50 degrees centigrade and 300 kPa at a molar flow of 100 kilomoles per hour with a pressure drop of 25 kPa at the shell and 10 kPa at the tube. Okay, so with the same parameters, we're designing a propane refrigeration loop and a propane refrigeration loop with the product from the expansion valve passing through a heat exchanger and back to the compressor. Okay, so let's get started. Here we go. Okay, the question says a vapor phase propane. So we need propane, and we'll be using Penn Robinson. Okay, our material stream holds propane at its purest, so composition should be 1. Okay, conditions: propane in its vapor form at 50 degrees centigrade. And all right, flash calculations have been done, and we need 100 for flow. Okay, so this material stream is fed into a compressor. Okay, and we have the energy stream to be comp Q, and it was compressed to have a pressure of 2000 kPa. Okay, so the pressure here is 2000, and its composition is 1. Okay, oh, I'm sorry, 2000 for pressure, not temperature. All right, here we go. It's converged, and we'll send to a cooler to cool it off to 25 degrees. All right, to the cooler to cool it off to 25 degrees. Okay, our energy stream is called Q. All right, let's go there to make it 25 degrees. Okay, 25 degrees. And the question said there was a change in phase from vapor phase to liquid. All right, so we have to change the vapor fraction. All right, here we go. So this product was also set to an expansion valve, okay, where the outlet pressure was 200 kPa. All right, so I'm going to add an expansion valve here. Okay, and this is a valve. And the worksheet says the pressure was 200 kPa. Okay, and it was heated to its startup parameters. So we need a heater here. Okay. And they said it was heated back to the required startup parameters. So the parameters is also the same as 1, so we'll go to 1. All right, so it requires an energy stream. What do? We'd say heat Q. All right, so the propane loop is done. This is question number 1. This is question number 1. So let's do some flow sheet modification. Okay, this question number 1. So let's go over to question number 2. So this is question number 1. They say with the above parameters, okay, you should make 4 go through a heat exchanger and back to the compressor. All right, let's get started. Here we go. So we get a heat exchanger ready, and we have to discharge that stream from the heater. Okay, so since it's going to go into a heat exchanger, it's going to come out from an outlet stream. So we need another stream here. So there's an external stream we have to absorb heat from. So we add another one here. Okay, and it's definitely going to have an output stream too, so we'll need another one. Okay, so maybe some flow sheet customization. Now back to the question. The question says the inlet of the shell side is in a vapor form and possesses 50 degrees centigrade of propane at a pressure of 300 kPa and a molar flow of 100, and it is a pure propane. Okay, so this is going to go into the system, and this is going to go into the system. All right, so here we go. First we'll name it heat exchanger. Okay, now it goes in through 4, the tube side, that's the propane loop, and comes out of 5, and the external comes in, which is 6, and out with 7. Okay, so what's the next situation? The next situation says that there is a drop in pressure at the tube side of 10 and of the shell of 25. Okay, now the system is underspecified. Okay, so there it is left for you to choose what phase the output ought to be. Okay, the output of the shell side. I like to choose a liquid phase. Okay, here we go. All right, we have a cross, a temperature cross. I like it. And the next class I'm going to show you a little trick on how to get this temperature cross out. Most time it's used, most time it's not. It's a technique in heat transfer. Okay, so most time it's being used, most time it's not. All right, for now let's let that go. But if you like this video, like it, subscribe, and click on the notification button so you have a notification on the next video. All right, the job is done. It's out here. Okay, and now what's left is sending it back to the compressor. Okay, so what do we do? Okay, the inlet of the heater has changed from 4 to 5. All right, okay, here we go. So question number 2 has been solved. Easy peasy. All right, if you follow the right steps, you get the job done. I tried my best to make sure everything is explained in a manner you can do this on your own. All right, okay, so this is it. You can do all the flow sheet modification if you like, but this is what question number 2 was talking about. And let's see how much temperature drop we had. All right, we had a temperature drop of -16. All right, -16. All right, okay, yeah, we have -16. Everything we have here is in its liquid state. All right, okay, we can choose to make it a gas state, but we want it in a liquid state. So from 50 degrees centigrade to -16 degrees centigrade. The job is done. If you have any questions you'd like to ask, just send me a message, and definitely in the feedback I'll give you some response. That's all for now. See you in the next video when I talk about temperature cross. Right? Take care of yourself and do more practicing. Have a good day.